Hello everyone, this is the IFC Architect, and welcome to the new Bonsai first major update. BlenderBim has been renamed to Bonsai. There's been 1,357 new features and fixes, so probably the biggest update of the last 2 years. Alright, so if you want to get the new add-on, you can go to bonsaibim.org. If you go to blenderbim.org, it just redirects here now, essentially. So if we click on that, we can see it now just says Bonsai, but it's the same layout, it is the same website, it's the same add-on. This release simultaneously contains a ridiculous amount of sweeping under the hood changes and UX work. Due to the sheer volume of new stuff and changes, please treat this release as more experimental than usual. Bin testing and reporting bugs would be really appreciated. If you want to try something out and you find a bug or a problem, please report it and it can be sorted out swiftly. Okay, deep breath, get ready, go. So this is our new Bonsai release. You can see there's a little bonsai plant and then the bunny, and then the new Bonsai, well, it's the same old logo. It's the B logo. Hello Bonsai, rebrand from the BlenderBim add-on. The same software, same community, new name. The BlenderBim add-on is now known as Bonsai. What initially started as a discussion with the Blender Foundation about their updated branding guidelines has resulted in a completely new, distinct brand. Bonsai is a comprehensive interface to the IfcOpenShell suite. Our name reflects the precision, detailed craft cultivation, and community behind the shared vision. The name was decided by a community in 8 pages of forum discussion. There were tons of other names considered. Also, rabbits next to the little trees are so cute. Absolutely. Okay, the first big one, support for IFC4x3 geometry. Alignments, linear positioning alignments, elements, and references are now supported. IFC4x3 is now an official ISO standard. It's the latest one. Many users in the infrastructure space are asking where can I view my infrastructure geometry. Some viewers won't show 2D or 3D curves, let alone infrastructure curves. This also includes more complex 3D forms like sectioned horizontal solids. There was a huge amount of work to achieve this over many months, and the best thing is that it's invisible to users. Just load your models. The next one is the upgrade to IfcOpenShell version 0.8. We've been using 0.7 until now. IfcOpenShell has had an incredibly huge refactor in the meantime. The significant changes mean that the API signatures have changed. Users will immediately notice that Bonsai and the rest of the IfcOpenShell ecosystem now share a release cycle and version scheme. That's right, we are now in version 0.8.0. Previously, Bonsai had its own version number based on the dates, absolutely. Stable and unstable releases were not distinguished. If IfcOpenShell had its own version number 2, but used a commit hash to distinguish builds. Version comparisons couldn't be made, and it was unclear if the API was compatible or not, even with the IfcOpenShell ecosystem. The rest of the ecosystem, IFC Clash and IFcCSV, etc., had no versions at all. Documentation was unversioned and published sporadically, and these were all released at different cycles on different channels. It's quite a mess. Now, everything has exactly the same version number, 0.8, and the same release cycle every 2 months, essentially, and is distributed the same across all the channels. All in-between versions, unstable alpha builds are now distinguished using Semver-compatible versions. Channels are now also consolidated. With everything PyPI added, IFCDiff, IFC4D, 5D, CityJSON, and FM, and the infamous IFcOpenBot build now redistributed in the main GitHub releases channel. All libraries expose a version variable you can use to compare. The biggest user impacts for IfcOpenShell is that it now supports multiple geometry kernels. Historically, only OpenCascade was supported. Now we can also use CGAL or a hybrid of both. Some shapes with CGAL and some shapes with OpenCascade. This also means that in the future, more kernels, smaller kernels, or tailored kernels can be used. This addresses a huge shortcoming in OpenCascade. We're dealing with mesh-like geometry with slow. This means that in the future, loading models can now easily be twice as fast. However, right now, work is still being done on stability and feature parity. So unfortunately, this release comes with a speed slowdown regression. It is very minor. If loading huge models quickly is important, you may wish to use an older release until this is addressed. Users can now test an experimental CGAL or hybrid kernel in advanced mode to see what the current state is. Expect some stability issues. Like Dion has mentioned, this is an experimental, kind of more experimental release, but they have already dealt with quite a number of issues. This also means that in the future, it's a step towards being able to bundle smaller versions of the IfcOpenShell WASM for the web. So it's just showing an example of the geometry library and the options you have. OpenCascade, CGAL, CGAL Simple, and Hybrid between the two. In the IfcOpenShell Python API, it's been completely refactored to use the new static functions from the previous release. This means that a general incremental speed up across everywhere, and a few minor bugs fixed across the process. Documentation now also only uses the static functions. UI tests are also now easier and more fun to write, and can test what the users see in clicks. Great stuff for preventing regressions in the future. Okay, the new wall polyline and measure tool. To draw a wall, first enable snapping, shift to right mouse button and set the 3D cursor. Then Shift A to add a new wall, and then R to rotate, and Shift right mouse button to the distance point of each wall, and then Shift E to extend that wall. That is the old process, essentially. How about this? To draw a wall, Shift A to add the wall, click the first point, second point, then Enter, or right mouse button to click to finish. Alright, so I've just got my Blender file open, I've got a Bonsai project created, and I'm just going to select a 300 wall with the wall tool, and then here it is Shift P, and then you can just click, 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 and then Shift C to close it, and you press Enter, and it will generate a wall just like that, however you want it to. If you want it to be orthographic, you can just say Shift P, click, and then just tap X, and it'll snap in the X direction, Y in the Y direction, so on and so forth. It's very, very fast and intuitive. Shift C, Enter. All right, that's it. Drawing walls should feel intuitive. This new approach by Bruno Perdegal is exactly what users expected, thank you Bruno, when drawing walls. With built-in snap, clever ways of projecting or aligning wall start and endpoints, quickly typing in the length of the wall as you draw it, knowing at what height your wall is going to appear as you draw it, undoing backspace segments on the wall tool as you draw it, and auto-closing loops, press C, and drawing multiple wall segments at once, which are auto-joined together. Work has also started in icons and more usable horizontal bar. There is also a new measurement tool. You'll notice this follows a similar approach to the wall tool. If you can use one, the other one uses the same logic, essentially. Where here, if we have the wall tool, and I press N, we can say load thumbnails, and you can see if I select the walls, there's considerably more tools available here with a lot more annotation, descriptions, essentially, of what each one does. It's a bit more fleshed out. Then for the measure tool, we have to select the explore tool first. And then here at the top, you can see it says Shift M. That's the hotkey. So we can say Shift M, and then we can snap to a point and we can measure it. And we can measure up, we can measure sideways, we can measure what everything is, essentially. And it's snapping as it goes, basically. Right, that is it. So now there's icons for extend, but, miter, unjoin, merge, split, rotate, flip, and voids. And then here's an example of the measure tool. Geo-referencing, better false origin handling and coordinate operation support. Handling coordinate systems and large coordinates has seen a complete overhaul. IFC defines all geometry in terms of the local engineering coordinate system, and additionally may define a coordinate system with an transformation to convert between local and map coordinates. Previously, all models were loaded such that the Blender origin coincided with the IFC local engineering origin. If you had two models that were geolocated in different parts of the world, or different parts of the same site, Bonsai would still load their local origins on top of one another. In general, all IFC viewers have this incorrect behavior, except for specialist software dedicated to showing properly, like IfcGref or ArcGIS. Bonsai now supports federating models together, true to their map coordinates, not just their local coordinates. You can take many models across a city or site with different origins, project norths, or even project and map units, and they'll all come in correctly from both opening and linking and, yes, merging. Even obscure combinations of both map conversions and rotated custom world coordinate systems are handled. To my knowledge, this is the most advanced and correct implementation out there. The only thing not supported is reprojection across different coordinate systems. In addition, where coordinates are very large, and where there are conflicting, irreconcilable coordinate ranges within the same model, Bonsai's ability to pick a meaningful, session-specific false origin is now faster, more accurate, and more customizable, including new disabled mode, and handles really strange coordinate combinations which we see out in the wild. Users can also now interrogate elements with problematic coordinates and fix them, or set temporary session-specific project north. There's new simple-to-use set false origin patch recipe that lets you pick a point and set the map coordinates at the point, with that point being the new local origin. In the past, editing these incorrectly georeferenced models would be a hit and miss. Now it's actually possible to do regular geometric editing in this situation. What makes this extra special is this also works with IFC2x3 using the fallback georeferencing property sets. We also support all new coordinate operations in IFC4x3. Editing a world coordinate system, WCS, is now possible in Blender interface. Editing angles for true north and grid north now auto-calculate Syscas, ordinates, or vice versa for ease of use. Understanding exactly how georeferencing works in general, let alone how it is expressed in IFC, is not an easy task, not at all. You can now turn on a visualization which shows clearly where is the project north, where is the map north, where is true north, and if you have any session-specific overrides, what is defined locally and what is defined as transformation, etc. There's also a simpler coordinate conversion calculator, and all coordinates always show with units to prevent ambiguity. We hope for this to be a reference implementation for the industry. It is very comprehensive. Okay, so we're in Blender with Bonsai. What you want to do is go to the project overview, and then you go to geometry, and then this is where you'll find geo-referencing. So you can click on that, and you'll see most of the time it'll say not geo-referenced. You're just going to say plus, and it will add in a set of different tabs that you can edit. So it says here EPSG3857, that's kind of the map system it's using. And then we've got eastlings and northings. You can input that information here with the little pencil icon. Then there's also a world coordinate system here, which we can edit there as well. And there's also true north, which we can edit there. And then to visualize all of this, we just need to click on the little should visualize icon. If we zoom in, and I'm just going to go here, and we can see here there's our project, grid, and true north, which are all different, all different things, all aligning at the moment. And if we just want to adjust these, we can edit this top one here, and we can put in an angle, let's say 30 degrees. And you can see that adjusted our grid north, even though our project north is still straight up. And then here with true north, we can edit it as well. There's also an angle we can put there. I'm going to say 45 degrees and say edit, and there true north has been adjusted. It's a very comprehensive system. All right, moving on. BCF version 3 support. In addition to a ton of BCF bugs fixed by Bernd, thanks to Andre, the Bonsai interface now has support for loading and creating BCF XML version 3 files. Previously only BCF version 2.1. Hooray! Thanks for the update. Quite a large change and addition. There's a new web interface for scheduling, Gantt charts, and more. More is 2D drawings and other stuff. Despite Blender's phenomenal extensibility, there are some areas where Blender's interface falls short. It's great at 3D, but not so great at spreadsheets, page layouts, Gantt charts, long-form text areas, and highly customized interface widgets. In contrast, the web is really good at this type of flexible interface, and vice versa. It doesn't do well with graphics. What if we could have the best of both worlds? Ziad set out to do exactly that. Bonsai's code is largely decoupled from Blender. This means that we can reuse the exact same code across any interface or app, like FreeCAD. Ziad has now built a new WebSocket-based web interface that you can launch alongside your Blender session. For this first release, you'll notice that spreadsheet and scheduling now have defaults to displaying tabular data directly on the web instead of having to save the file and reopen it in another spreadsheet hot software. This is a live connection, so you can click rows on the spreadsheet and auto-zoom into the object in 3D in Blender. So it's just showcasing the view inside of Blender, over here, editing the spreadsheet. And then another module with support is the Gantt chart module. Previously, Gantt charts were statically exported. Now you can have a live Gantt chart showing your construction schedules and edit your dates from the web interface and see the Gantt chart update live. It is very useful and much more intuitive. So here is the web interface. You can see there's a Gantt chart being displayed, and you can see updating different elements inside of the chart. Yes, Yasim, managed to sneak an implementation of a costing module as well, which is amazing and much more intuitive through a web interface, to be honest. You can now also browse drawings from the web, quickly and visually switching between drawings and sheets on the web and see previews of them instead of having to launch them separately. Absolutely, it's quite a useful way to just manage your drawings throughout the whole project. You can now also connect multiple Blender sessions together and see their data together in a shared web interface. This is just the beginning. For those who want to learn how to build your own web interface, a tutorial demo module has been extended. So we're back in Bonsai. So for this, you need to save the file, you need to create a plan, and from here, we're just going to print, we're going to activate, we're going to print the drawing, and then we're just going to use this extra new document, this new button that says Open Documentation Web UI. You click on that, and it will open up a new web user interface that you can use. Select the IFC. It says here connected Blenders 1, and then IFC file you've got selected. Then you can just select we're in documentation. These are my two drawings in the file, basically. And we can go to construction sequencing. I can load whatever construction sequence we have. You see this is a Gantt chart that I made in the IFC file. It looks pretty good. You can edit it here. And then costing, same story. And we just elaborate on that. And you can see we've got values and lengths and quantities. These aren't real, but it's just to showcase the web UI. And yeah, there's also schedules and BCF, IDS, and facilities management. And this was part of the Google Summer of Code. And Ziad is the main contributor responsible for this web interface. So thank you so much, Ziad. Experimental light simulation integration with Radiance. Although Blender offers very powerful artistic rendering capabilities out the box, lesser known is how to perform light simulation in Blender itself. Essentially, Eevee and Cycles in Blender, their default rendering engines, although they are fantastic, are not really accurate in regards to light simulation, and Radiance can fill that gap. There are already add-ons for such as V0.8.0, which can do such things, but these lack a close integration with IFC. IFC can store lighting styles and light distribution data for light sources, and reference external style definitions. It would be great to combine the best of scientific and artistic worlds and perform photometrically accurate luminance renderings within a tolerant certainty that is also beautiful, textured, and evocative. Absolutely. Chirag, who is the Google Summer of Code contributor, has made an excellent start to this. We now ship with Radiance and can produce renders directly from the IFC with Radiance. Users can pick simple physical material definitions from Spectral DB, define a camera and sun location based off of IFC True North and Geo-Referencing data. The module handles the conversion from IFC to OBJ to RTM formats under the hood, and users can configure basic rendering settings and material mappings. So this is also taking us a long way to integrating Blender and Bonsai into kind of like a seamless approach. All right, next one, which is also quite exciting. There's a new solar analysis tool. So Blender has an excellent sun position add-on, which is there by default. If you are an architect or work in the AC industry, it is, and you use Blender, this is probably one of the most useful ones because it gives you accurate lighting positioning information, which is able to calculate azimuths, altitudes, solar positions, and lemmas. However, effectively using this add-on for architectural, solar, and shadow studies, use cases required a bit of Blender knowledge, absolutely. There's now a completely new solar analysis panel which extends the sun position add-on with better visualization of the sun position, easier setting latitude and longitude, reads from the IFC site, easier setting of UTC offset, auto-calculates time zone, and auto-sets true north from IFC true north. This is awesome because previously to get this information you had to have it duplicated in the Blender file, and now it's saved in the IFC and it's also represented straight out of the IFC. It also supports a one-click view setup for creating shadow renders with a configurable shadow intensity, which is very nice. It's very similar to the aesthetic of SketchUp's auto shadows, except accurate sun information from the get-go, which are often a requirement for architectural submissions, absolutely. There's also a view from sun mode, which places the camera on the sun's position, allowing you to quickly scroll through key dates to check minimum solar access requirements for larger projects, such as multiple apartment towers. Absolutely, very useful, very good. And then you can see a GIF of it working in real time. It's awesome. For this, you need to have the Bonsai add-on activated and also have the sun position add-on activated because they rely on each other for this. Alright, Blender 4.2 extension support. This is quite exciting. This release marks our debut on Blender's new extension website. Bonsai is one of the first add-ons to be officially on the extension website, which is pretty amazing, and it's already quite popular. Blender has now standardized how to distribute extensions, add-ons, and themes on the web, where they can be searched, installed, and updated directly from Blender itself. We are super proud to be listed on the main Blender extensions website, absolutely. This means users can install us easily, and in a single click inside Blender updates the latest version, yes. This also means that using the latest stable releases can update every single day with a single click. There is Bonsai, formerly BlenderBim, already has 10,000 downloads and 23 5-star reviews. If you click on that, you don't have to click here. You don't have to say get add-on. This can all be done through Blender. So I've got Blender 4.2 open here, and this is the new process to install Bonsai the simplest way. You don't have to download anything. Just inside of Blender, you're just going to say Edit, Preferences. You're going to go not into the add-ons, but into the Get Extensions tab. If you've never used this before, it's going to ask you if it can connect to online, and you're just going to say yes. That's so it can download it through the extensions store. And then here, where it says search extensions, you're just going to type in Bonsai. And then it doesn't matter how many options there are. The top one will be the last stable release, and then the bottom one will be the daily release. So it's up to you which one you want to go for. We're going to go for the stable release, and we're just going to say install, and it's just going to download in the background. It will install, and then it will activate. So you can see there, it says installed there, and now it's just activating the add-on. All right, so I'm just going to close that. And you can tell that the add-on has been installed because we have a new BIM workspace here at the top, and we have these new tool icons on the left-hand side. All right, that's it. This also means that workarounds previously required for updating and uninstalling are now fixed. Unfortunately, this does mean that we are dropping support for Blender versions 4.1 and older, as well as Python 3.10 and older due to lack of resources. So essentially, if you are using a Blender version that is 4.1 or older, you cannot use Bonsai that is on the extension store. I would recommend, if you're still using an older version of Blender, use BlenderBim from the last stable release, 24.06.02, That was an excellent release, and it is quite stable. I would recommend updating if you can. All right, the next one, consolidated material and style handling. There's been ongoing work to restructure the way materials and styles are handled. This work continues in this release with more stability and more obscure cases handled. The biggest changes that we had in the past, a Blender material could either represent an IFC material, an IFC style, or both at the same time. This unnecessary complexity led to no shortage of bugs and limitations. Now, Blender materials accurately only refer to IFC styles. Physical materials are managed separately. This is mostly code simplification, bug fixing, and minor speed up during loading and saving, but means that in the next release we can do more cool things, absolutely. Also pretty neat, you can now press a button to assign a style to a selected object, which makes it much simpler, I'll be honest. So back in Bonsai, you want to go from project overview to geometry and materials. Then we're going to come down to styles, and then we're just going to click load the surface styles. These 4 should be in there by default if you're using the IFC4 demo library. We're just going to select one of our objects, go to styles, we're going to select the style, I'm going to select frame, and then it's this little paintbrush icon, assign style. That's it, as simple as that. All right, moving on. Flexible collections and new Spatial Manager. In previous versions, the way of managing the spatial tree was done in the outliner. This had a number of limitations. For larger projects, you'd end up with a very, very long list of objects, and it wasn't possible to get an understanding of what objects you actually had, or even how many stories or spaces you had. Instead, you had to collapse and expand collections and manually filter and count to get an understanding of larger spatial trees. Another problem is that it took away the flexibility of Blender's collection system. You couldn't have objects assigned to multiple collections, and you couldn't ad hoc create or reorganize custom collections or temporary grouping and visibility like regular Blender. This led to a lot of bugs unless you knew exactly the exact rules of what could be nested in what. This also blurred the lines between spaces and objects groups versus aggregates and sub-element groups. Essentially, if you had an aggregate shared across multiple floors, because of the old hierarchy system, it didn't really work. You didn't really know where the aggregate was sitting. In IFC4x3, other relationships like covers or nesting is increasingly common, which could lead to very deep nested spatial trees. This deep nesting and collection-based way of managing the tree also meant load, save, and drawing generation times were unnecessarily long, and had a risk of creating sync bugs. A huge change has been made to how the spatial trees managed to address all of this. This is a new spatial decomposition panel with friendly icons showing only the spatial structure. A split panel below shows elements contained within the active space, grouped into types with counts per class and type. At a glance, you can now see more meaningful results like I have X stories, X walls on level 2. There are also dedicated buttons for isolating spaces and toggling visibility, which is very useful, and quickly selecting elements within a space, recursively and non-recursively. Previously, you have to scroll constantly and use up to 3 possible visibility controls to achieve the same thing. So if you've already been using BlenderBim, when it comes to Bonsai, you're just gonna have to change your muscle memory a little bit to use this new spatial decomposition tool. It is very intuitive, it is much faster, and you get much more control. But everything you used to do in the outliner when it came to project organization, you now do in the spatial decomposition tool. So you can see it's quite a bit more straightforward, and then it decouples Blender's outliner from the IFC structure. You can now also create new spaces from the spatial panel. These also filter only to valid subspaces, for example. It doesn't allow you to create a bridge inside of a room, but it does allow you to place a road on a site. It also has separate dedicated search filters for spaces and elements. These search filters search not only for names, but also long names. Previously, especially for rooms which only have room numbers or buildings with short codes, it was difficult to quickly search for room names or building descriptions, but now you can do it. So there you can see an example of it. Over here, you've got my building, basement, floor. They've got different icons now. And then we've got the rooms. You can see it's quite easily demarcated and it makes a lot of sense. And then you can see inside of the IFC building story, there's 202 contained elements, and each of them are categorized appropriately. This also leads to faster drawings, load, and saves, and less bugs. Users can now also set a default container, which is quite useful. Over here, you can see default first floor, IFC building story. Previously, new objects were created in whatever collection was active in Blender and contained whatever IFC element it correlated to. This would lead to a lot of breaking of the correct hierarchy, spatial decomposition, essentially. Unless you are a Blender whiz, it isn't clear where your objects are being added to, or if it's valid or not. Now your nominated default container is where all new objects end up and impact things like where new walls are drawn to. The big change means that managing spaces can now be done in this new panel. Reorganizing and using multiple non-IFC collections in the outliner is now completely decoupled and freeform from your own organization and won't change or break your IFC structure. For those who wish to create their own session-specific workflows, this is a big win. And then you can just see there's a GIF of things being managed from the spatial outliner. Okay, so essentially we go to the project overview, we go to spatial decomposition, which is a new panel. And you can see at the top here, we've got the site, building, story, and then we have inside of that, we've got the 9 elements. It's the 9 walls, essentially. All right, that's it. IfcTester supports now version 1.0. IFC Patch is now friendlier and batch process models. IfcTester now supports IDS version 1.0. IfcTester now supports the new requirement for IDS for lowercase booleans, or 0 out of 1, has more detailed failure messages for predefined types, and handles restrictions on data types. JSON reports are also more comprehensive for those integrating into their own systems. Auditing nested relationships for IFC2x3 is also now supported. IfcTester can also select multiple IFCs and multiple IDSs and run them all in one go, a game changer for large projects thanks to BD. Reporting is now redesigned and shows more information like where the IFC schema version is accepted in the IDS, as well as passing elements, not just failures. When an IDS specification applies to an occurrence, the result automatically groups occurrences by type if they exist and clusters occurrences so that you can get a feel of common problems by type rather than a huge list of occurrences. IFC patch recipes are now easier to use. There are new drop-down menus to select configuration options, file browsing to open files, and sensitive coordinates preserves precision. You can now merge projects in bulk rather than one by one. So this is the IDS output, and it's quite useful. All right, next is improved color legends. When auditing models, we often want to visually check whether properties are correct. The color by property panel now lets you quickly pick a property from an active object and apply a color legend to it. 2 new color schemes are now available for categorical and qualitative data analysis, and new view presets to toggle flat coloring to make colors pop and easy to spot. Nice. For quantitative analysis, there are 4 new color legends, 2 for min to max ranges and 2 for diverging palettes highlighting the average, with an automatic or custom minimum and max. If you wanted to quickly color code your model to show carbon intensities for different materials, you can now do so, or quickly spot anomalous volumes or lengths during a quantity takeoff by setting maximum and minimum thresholds. It essentially takes information that was previously you had to trawl through a list and makes that incredibly visual and easy to spot when you're looking at the model. What you want to do is come over here to Project Overview, and then we're going to go all the way to the bottom, Grouping and Filtering, and then you're going to go to this new tab, Color by Property, essentially. So we can color by query. We're going to use class as our generic one. I'm going to add in a few more classes just so you can see the difference here. So we're going to add in a door, and we're going to add in a few windows into some of these walls, basically. Okay. So custom query, class, and then I'm just going to leave it on the default palette, and I'm going to say color by property, and you can see suddenly it's very visual and it's very easy to distinguish different classes, and that's the whole purpose of this thing, right? All right, moving on. The new bisect mode and freestyle mode for drawings. A drawing is composed of a possible raster render in the background, followed by projection background line work. The line work is then potentially filled or colored in, and then there's actual cut objects, and finally the annotations. Previously, and here's an example from opening design. Previously, the hidden line rendering for background projection work, as well as the cut line work, was calculated by OpenCascade. OpenCascade is quite slow to perform this. This doesn't work well for organic forms. For heritage or landscape architecture, the new default bisect cut mode uses Blender's built-in bisect tool to perform the cut, and is generally faster and more robust against strange and non-manifold geometry. There's also an option to use Blender's freestyle renderer to perform the background projection line work. This is significantly faster on complex scenes, being easily 2 to 10 times faster. As a trade-off, it's less accurate but it may be sufficient for your situation. It also doesn't allow for vector background fills yet. On the flip side, it does mean we now support producing vector line work for perspective renders, which are quite awesome and quite useful. So here are 2 beautiful renders, thanks to Manuvaki, TheoryShore, and Kolopav to test the model shown above. To drawings and documents, we're going to go to drawings. We're going to go to our My Story Plan. I'm going to activate that. I've added in an object that has quite a bit of tessellation. And what we're going to do here is I'm going to activate and print this drawing. And you can see there, this is using our original cut line work mode. So if we go here, it says line work mode, OpenCascade. So that's the original one. And you can see the cut mode, there's the other option, bisect. So that's just a bit faster way to generate drawings, essentially, but it's a little less accurate. So here we can change this from line work mode to freestyle. And the first time you do this, it's just going to take a bit longer to generate the drawing, but don't worry. We're going to activate it, and then we're just going to print again. And you can see the difference there. Here is the original line work mode, which is OpenCascade. So this is Open Cascade. You can see there's all the tessellation, the triangles. And then here is Freestyle, and you can see it gets rid of the triangulation, basically, the unwanted triangulation. All right, the other advantage of Freestyle is we can now do perspective renders, basically, perspective shots. So I'm just going to delete this wall, and I'm going to delete that one, just to make something slightly more interesting. And what we're going to do is we're going to go now to Model, and you can see here next to Orthographic, there's a perspective option. We're going to say plus. It's going to add in that perspective camera. So in model view, there will be a perspective camera. You just need to activate it. We saw that it was facing down, so I'm actually just going to go out into 3D space, and I'm going to bring this up, and I'm going to activate it again. What I'm going to do is just increase the depth so it can see more of the scene. So activate, there we go. So we can see more of the scene. I'm just going to grab this, and I'm just going to use the Explore tool, and I'm going to say walk mode, so Shift W. And then that will allow me to walk around using W, A, S, and D, or your arrow keys to move the camera around. And I'm just going to choose a fun angle for our perspective, like this perhaps, just from above. And then we just need to increase our depth so we get more of the scene in the shot. There we go. Okay, so the perspective shot. So this has to be done with Freestyle. Open Cascade cannot do the perspective shots. So we're just going to say Freestyle. We're going to activate, and then we're going to print this. And there you can see there is a perspective shot. It was basically instantaneous. And you can do any number of complex structures, buildings, shapes. All right, that is it. Sponsored development by BD and Bruno. Thanks to our financial donors, we've been able to sponsor work by BD and Bruno Perdegal. It's incredible how many people chipping in from $5 a month can allow us to accelerate development. We already have $2,300 per month in funding. Will you help us reach 2,500? The more people that can work on this, the faster we can address bugs, create more stability, and expand the actual features of Bonsai. Check it out here at the Open Collective Open Source BIM if you haven't already. So over here, if we open that up, you can see here you can contribute, and you can see the things that have already been reached. We're always looking for people to test, to help fix bugs, to report, and to add to features, or just do some good old-fashioned stability adjustments. So there's so much more. It's really hard to capture absolutely everything which has changed, but here are a few stragglers. The spatial containment panel won't show for spatial containers. Only allow aggregates to elements which don't have geometry. Improved type hinting, generally everywhere, and better auto-completion in API methods. Ensure you can only add certain quantities for different resources. Fixed bug removing resources in IFC4x3. Fixed a bug where cubic meter quantities had the wrong unit. Fixed bug where orphaned aggregates were never shown when loading a model. New get contained utility function. Blender panels now only exist in drop-down switch and other Blender tabs hidden by default to prevent confusion and lost users. Centered tab bar. You can now search, filter styles when selecting. Old complex selector syntax is deprecated, and drawing styles now use a new selector syntax. General cleanup to prevent orphaned elements when removing scheduling related entities. Coordination mode, merge advanced modes deprecated in favor of new link IFC feature. Support invalid spatial trees from 12D. IFC object/edit modes, IFC meshes are now hidden if there is no IFC model. Linking IFCs now also include spatial elements, which is brilliant. JSON schema definitions have been purged. We now only use dynamic schema data from IfcOpenShell. Generally, better error reporting and handling across many invalid interactions, especially for using blend files or discarding errors. Essentially, if you want to preserve the link between the blend file and the IFC file, it's just kind of improved that experience. The codebase uses schema identifiers, so schema geeks can technically test minor IFC version variations. Fixed critical bug where quantities always used IFC4 quantities. Remember, IFC2x3 does not have standard quantities. You can now use a cache or force a new load when relinking in IFCs. Fixed a bug where 2D angles weren't correctly passed in offset object placements recipe. Fixed a bug where merge duplicate types would trigger listeners in an active Blender session. Tessellate element IFC patch recipe now supports product types. minor fix to IFCFM to derive occurrences from types and make it easier to override. Various bugs fixed in IfcOpenShell quantity calculation engine in IFC5e, and various bugs fixed in upgrading models to Ifc4x3. Multi-literal text annotations can now be reordered. Oh, that's very nice. More accurate quantity takeoff for beams and flow segments, pipes, ducts, cable trays in IFC5D. Migrating calendar types from IFC2x3 to IFC4 is now supported. Remove unload project button, superseded by convert to Blender file operator. Move new project wizard into its own panel and actually title it new project wizard for clarity. Improve UX around opening, creating, and saving. Absolutely. You can now open recently opened IFC models. This is a lifesaver. The tooltips now show the IFC version as well. Yay, absolutely. Fix bug where merge project didn't clean up duplicate CRS and coordinate operations. Fix bug where migrating links didn't change properties, critical for IFC2x3 Geo-Referencing. Fix missing door flip button. That's wonderful. UI asterisk indicates if the placement is not yet synced. When removing the active representation, it now switches to another available representation, which is really great for clarity. Be able to search, select objects in scene from the spreadsheet, import, export UI as well, which is amazing. Support renaming materials, styles, and profiles by double-clicking on them. Oh, it's just so much more convenient. Materials UI now indicates active class. Significantly faster quantity takeoff due to optimized shape utilities, absolutely. Add to debug UI an operator to toggle detailed IfcOpenShell logs. Unit panel now shows length, area, and volume unit for convenience. Allow warning and background decorator colors to be configurable. BIM tester interface deprecated and removed. New operator to restart Blender quickly. Ooh, that's nice. Support assigning BSDD classifications in IFC4x3 as well. Various bug fixes in BSDD and UI improvements. And for those that don't care about native IFC and just simply want a geometry importer, file import IFC geometry only has been added. A small thing, but a huge quality of life improvement for those looking for it, absolutely. If you just want to pull in IFC geometry. Members, like stringers, can now have a stair modifier applied as they may be used to support stairs. Wow, that's awesome. And deprecate the old dumb stair tool and pie menu. Excellent. Okay, all changes can be found there. Thank you to everybody who contributed to the commits, and thank you to all of the donors. We appreciate it, everyone. Thanks for watching, everyone. I hope that was helpful. We're in a new era of Bonsai, which is very exciting. And just a heads up, the next release as of February 2025, version 0.8.1, is also out, and that video should be ready tomorrow. So look out for it. Just a heads up, I also have a Kofi page if you want to help support making these videos, and thank you to my Kofi supporters. Awesome. Thank you, everyone. Bye.